This conference will now be recorded.
Okay, welcome back everyone. Good morning. As I have informed everyone regarding the machine learning end-to-end project which I have shown last week, that was just a touch-up to let everyone know how the whole machine learning engineer thinks and implements the logic. Thank you for the amazing feedback. I sincerely appreciate it. Most of them have come back to me telling they have enjoyed it, and some of them have told the whole session is great. And last 30 minutes was so confusing, and it just went so fast. I totally understand that. The reason behind it is, you were not aware of the basics behind it, and that's the reason those 30 minutes was out of went over your head, which is totally understandable, and I accept that. So today I have decided to let you know. So the last session was you don't know anything about machine learning, and you have seen the whole project of it. So now today you are going to see what is machine learning from scratch, understanding the fundamental concepts of it, and then we'll deep dive further on linear regression and other classification models. Okay, let's jump start into it. Let's not waste any time. Okay, first let's understand what is a machine learning. Basically, a machine trying to learn based upon the earlier experiences or the set of examples it has is called a machine learning. So theoretically, machine learning is a science or art of a programming computers so that they can learn from data. So there is a big difference here. The way machine learns from small set of data and the way machine learns from big data and huge data sets is comparatively very different. If we have more data, machine has got more examples. If it has got more examples, it can analyze the data more and can predict more accurately. If data is less, samples are less. If samples are less, examples are less. When examples are less, it tend to constrain the learning of models and algorithms within those limited samples. That's what it is. So let's understand the slight definition of machine learning. Machine learning is a science, or you can say it is an art of a programming computers so they can learn from data. So it's data everywhere. Now, machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. Perfect. Now, the most engineering oriented line for machine learning is a computer program is said to learn from an experience E with respect to some task T and some performance measures P if its performance on T as measured by P improves with experience E. It seems little confusing, but it is very straightforward. Let me explain you that. I'll take a pen here to explain you. Now, you have an experience E, okay? What was your experience? Let's take one example. My credit card had a fraud payment of 300 pounds on one fine weekend. That was my experience. Okay. Now, with respect to some task T, what was the task? Experience was a fraud detection. What was the task? That my card payment was done by someone else, which was not me. Now, performance measure. What is the performance measure? Right now, let's park this aside. We'll talk about it more detail in the subsequent slides. Now, what is the performance of task T? For example, don't get confused. For now, I'm comparing this performance measure P with number of occurrences. Did it happen once? Did it happen twice? Did it happen thrice? Perfect. That is performance P. Only for this example, take it this way, but we'll talk about this performance measures more detail. Now, what happens is you have a bad experience. there is a task that is entitled with the bad experience, and there is a performance with that, and you also have to deal with the performance of that task. Very good. Now, if the performance of task T is measured as P, okay, now the performance, if it is improved with experience E, okay. Now, what are we talking about? We are talking about one experience, we are talking about one task, and we are talking about the performance measure of that task, and the performance is measured by P, task by T, experience by E. So now let's rephrase the whole sentence. It is a computer program that is set to learn from an experience with respect to some task and some performance measures, and if the performance of the task is measured by P improves with experience E. Let's take another example now. I have explained you my credit card fraud happened, right? Now let me show you one other example. I have emails. Okay, I'm getting a lot of spam emails from one of the what I can say, from one of the marketing company. That marketing company has for you. Okay. Now, what is my experience? My experience is spamming. What is the task? The task that is spamming my email is coming from for you. And some performance measures. Performance measures mean, is that spam coming only from the name ending with for you, or with some other elements like foryou.com or youwishforyou.com or foryou.com kind of thing? How many times has this occurred? And now, if this machine has learned from an experience and took a decision to classify all the emails coming from for you as spam, is the improvement of the experience. Let's come back again. Initially, you don't know that the mail coming from for you is a spam. Now, your machine learning, your machine has learned from first experience that for you is the one that is a spam and has to be classified as a spam. This is one experience. In the next run, what happens is it checks for any other emails coming from such kind of marketing companies, so it can filter that and send it to spam folder. First experience is for you, and second experience is any such email IDs coming from other marketing. So what did you understand from this? From an experiment, from an experience zero, you learn something, and you now know how to deal with all other marketing emails. Now experience zero, experience two, experience one, like that. Your experience two will be kind of be able to handle any spam emails from any of the marketing company distribution. Okay, so in a nutshell, to understand this more clearly, your experience on one task with some performance measures of that task, if it is improved, is called machine learning. A computer is said to learn from an experience C with respect to a task T and performance measure P, and if its performance on that task T, which is classified as P, is improved with an experience T. That is machine learning. One interesting part is this guy has came up with this definition in the year 1997. I think I was in my ninth standard in 1997, if I'm not wrong. Not even ninth. I was in eighth standard, I believe. Yeah. So that's machine learning. Okay. Now let me erase this drawing and let's go back to the next thing. Now, so hope the first slide is clear. It is very simple. You got to have an experience, you got to have a task, and your experience and your task based upon the performance measure P and how it learns and implements that experience and task for the next occurrences is called machine learning. A machine trying to learn, or a computer is programmed to learn of the occurrences and build algorithms. Now let's go to next slide. Training set and accuracy. This is very important, guys. You need to understand the basic functionality of it. Now, for example, if you take a machine learning program and if you wanted to filter all the spam emails, okay, so the spam emails are the example I've told you just 1 minute back, but we'll approach a different way. Now, the example that the system uses to learn are called training set. If you remember in my last video, I have very clearly explained to you splitting of the data set from training set and test set is very important aspect for a data scientist. The reason is each training example is called a training instance or a sample. You run your algorithm or you run your models on that, get the results, understand how things are looking, and you do the same thing on the other one as well. Other one means uh, test set. Now, let's take this example. In this task, okay, one second, let me highlight this one. Look at here. In this task, the task T is to flag spam your new emails. The experience E is the training data, and the performance P need to be defined. We don't know that yet. Okay. For example, you can use the ratio of correctly classified emails. That's the performance you can judge. Now, once again, understand your task T is to flag all the spam for new emails. Perfect. The experience E is where are you doing it? You're doing it on a training data. Okay. And the performance measure P is not defined yet. But for example, let's take you can run the ratio of correctly classified emails. If you have 100 emails, the 100 emails, if in 100 emails you have 40 spam emails, in that 40 spam emails, if 20 emails are correctly classified as spam emails, that is the performance measure. Now, this particular measure is called accuracy. Very important, guys, and it is often used in classification task. So this is very important. What is training set and what is accuracy? Training set is nothing but that is a sample data on which you are going to run your machine learning model or an algorithm. Now, what is an accuracy? Accuracy is nothing but a performance measure that comes out of your run. First, say I have 100 emails. In my 100 emails, 40 are spam, but my machine learning model has identified 20 out of 40 as perfectly spam emails. What happens is if you run next time, it identifies 30 emails as spam emails. If you run third time, it will classify 40 emails as spam emails. Do you know why? The way how this works is your machine learning is learning from the samples it has got on every experience. The first time you run is one experience, the second time you run is second experience, and third time you run is third experience. It doesn't mean you have to run so many times to get the correct results. For the machine to learn from the data, which is kind of, it has to understand the way how the decision making and the classification works. So that's the idea of it. Okay, hope we are clear. We understood the testing set and we understood the accuracy. Perfect. Let's go on to next slide. Now this slide is why are we using machine learning in the first place? Why are we using machine learning? What is the benefit we get out of using machine learning? The first thing is we have already looked at the spamming emails looks like, right? So now if you see, you might notice some word phrases such as for you, credit card, free, and amazing. Anything that has a subject like for you, credit card, free, amazing. So what was the first classification? What was the first approach we did? The first approach we did is any email coming from a marketing company having for you at their domain. Now, what I'm telling what I'm asking my machine learning is try to learn from the earlier occurrences that If you see for you or credit card or free or amazing phrases in the subject, categorize that as spam email. I'm telling that machine was not aware of it. Now I'm giving instructions to machine, or on the recursive running of your model, the machine will come to understanding that okay, till now I have only looked at the recipient or sender's email and the domain name. But now if I if I correlate this data properly, I now sense that a subject which has credit card, subject which has phrase amazing, or a subject which has a phrase called for you is also a spam email. Now, what happens is first you would write a detection algorithm for each of the patterns that you noticed, and your program would flag those emails as spam if number of these patterns are detected. Okay, first time the machine has what machine has done is it has considered the sender's email and domain. Now looking at the data, you got an idea, yes, this can also be case. So you're writing a model and you're telling your system to detect this one also as classification, detect this one also as spam as part of the classification. Now you would have to test your program first, repeat the steps 1 and 2. Okay, now let's understand few fundamental basics here. I'll take a pen. Now study the problem. What is the problem? I want my mailbox to be clean. How can you make your mailbox clean? You do not want spams to be sticking in inbox. That is the problem. Now, writing the rules. Before you write the rules, you need to analyze your data. Okay. When I have run my machine learning model initially, it has filtered out all the emails coming directly from the marketing company's domain or email. That does not solve my problem. Now I have seen another problem that I have registered to so many companies from my Facebook or from my Instagram or from my LinkedIn. They're all sending me emails with useless subject which I don't need. Now I have to let model know, kindly go ahead and consider the emails with relevant subject like for you, credit card, and sender is a spam. Okay. Now you have written a rule. Very good. You are evaluating it. Evaluating it means you will run it on your test set. Once you run on your test set, you analyze the result, you see the accuracy, and you cross validate that against your training set. Or first you run on a training set and then go ahead and check it on the cross validate on the test set. If everything looks good, you will launch it. And if you see some errors, you'll analyze those errors and then start from the beginning to start the problem. This is the typical initial understanding of how your machine learning model or how we have to approach your machine learning model process. Okay, I'm erasing the drawings now. Let me go to next slide. Now machine learning approach. Okay, so this problem is not actually a huge problem. This is a very small basic ABC of machine learning which started in 2000s itself. So we have to start from roots. That's the reason why I'm making you more aware of the fundamentals of it. Okay. Now this problem is not trivial, to be honest with you. Yes, it's a very simple problem, but your program will likely to have more complex rules. Yes, we'll have many complex rules. For that purpose, what you're doing is you will have to spam your filter based on the machine learning technique that automatically learns from which words and phrases are good predictors of spam. Now try to understand the difference. In slide number 4, you wrote a model, and now you want your machine learning to form a technique that it can learn from which words and phrases are good predictors by spam. Okay. Hope you understand. Hope you got the difference. It's very clear. First, the emails coming from the direct email address of the marketing companies. Second, the registrations you made through Facebook, LinkedIn, and Instagram. For example, take Ghana, your online music streaming platform, or for example, uh, take some other examples like I get registered with Tony Robbins, Mel Robbins, Simon Sinek channels. So sometimes I get informative information from them, but sometimes I get marketing and spam emails from them. How can I categorize that? So in that case, your model must be able to learn by itself, forming a technique that it automatically detects the spams or predictors of spams from the words. Now, this is the most unusually frequent patterns of words, but it is quite hard for machine itself to do that. But what happens is this program will be much shorter, easier to maintain, and most likely most accurate. Okay. Earlier, what happened is out of 100, if you have, excuse me, out of 100, if you have 60 emails, in that 60, out of 100, if you have 60 spam emails, in the first run, 20 were detected as spam. The second run, 40 were detected as spam. Third time, the 60 were detected as spam. You know how this is happening? First, it only considered the marketing companies. I'm telling this again and again because you need to understand step one, step two, step three. If you don't understand the step one, step two, step three, your approach towards writing a model will mess up everything. So first is basic use case. Second is one step up the use case. Third case is cleaning up the whole use case. So first is how I can first find a spam email. Good, you're nice. Second thing is it the only way the emails are spammed? No, there are several other ways. What are they? The subject can be anything, or within the email you'll find some crazy fancy words which can be used as spam. This is step two. If this is yes, go ahead and run your model. If this has got some other possible chances of spamming, then go ahead and filter out that as well. So this way, based upon the information your model reads, it picks up the phrases and predicts that one as a spam email. This is one important approach. So step one is done, step two is done. Now you have reached a very complex step for step three. This is complex step, but the program will be much easier. Okay, let me take the pen and explain you. So studied the problem, you trained the ML algorithm. How did you train the ML algorithm? Case one submitted, case two submitted, case three submitted. Case one, the sender's email and the domain. Step two, the crazy words like for you, credit card, amazing. Step three, you try to read the whole content of the emails and try to figure out the possibilities of the mail that can be classified as spam. Okay, evaluate the solution. If it looks good, go and launch it. And if it is not good, analyze the errors. This is the crazy part of it. Question mark. The data is this data may keep increasing. This is the where a practical real-time best practices of a data scientist or a machine learning guy should come into picture. How? The model which you have built right now, is that capable enough to handle if more data is coming in future? Requirement number one. That is requirement number one. I repeat, the requirement number one is the data, the model you have written right now, is that capable enough to hold and work perfectly with best accuracy if more data is added? Requirement number two, if the data is going to change, for example, there are additional columns getting added, or your target is going to have more labels and features? If that's the case, will this model be able to run and give you the best prediction or best accuracy? This is the important fundamental that as a machine learning engineer should have an thought process of writing the models. Always make sure any model which you write must be capable of running in the long term on the new set of data, or the new data with the earlier experiences having more columns and more artifacts of it. That's the beauty. Now let me erase the drawings. Perfect. Let me take out the pointer. Now, this is the approach of machine learning. Let's go to next slide. Now, how can we adapt the changes? You know, your iPhone, you have iOS 12, 12.0, 12.0.1, blah blah blah. Every quarter or every month or when there's a bug, they release, right? Like that, your data keeps increasing. Whenever your data keeps increasing, how are you going to manage that? How are you going to make sure you need not have to rewrite your model from scratch? That's the thing. So now, I have underlined the important things which you must read through again after this class. I'll share the slides, so please read the slides carefully. Okay, let's go through this. A spam filter using a traditional programming technique would need to be flagged for your emails. That's perfect. If spammers keep working around your spam filter, you will need to keep writing new rules, right? Okay, I'm a spammer. I have my Hadoop ThoughtWorks channel has got around 700 subscribers, and I'm sending all the 700 subscribers a daily emails like watch this, watch that, a new video is updated. Some people like it, some people don't like it. So my amazing students have classified my emails as spam, for example. Let's take it that way. I want my viewers, I want to attract my viewers more. So what I did is I tried changing the subject and send it again. When I try to change the subject, the first time it won't go to spam, it will go to email because the subject is changed. And I have changed the words that their Gmail cannot categorize as spam. Now, in this situation, what happens is a spam filter based on the machine learning techniques automatically notices for you has become unusually frequent. Okay. Now, what happened is if spammers keep working on it, and if you have written your machine learning model perfectly such that if the subject is not changed, if subject is changed also, looking at the contents of the email, it can classify that as a spam. I repeat the sentence. In contrast means it can happen in such a way that a spam filter based on machine learning techniques automatically notices that for you has become unusually frequent in spam flagged by users. So what happens here is if you take this approach, let me point out pointer. Let me take the pen. If you take this approach, then you need not have to rewrite your machine learning model. If the spammers keep working around on sending an spam email as a general email, your machine will still be able to classify that as spam because when you have written your model, you added one additional step that this should go and work on new set of data also. What is the new set of data? The new set of data is spammers workaround, like just changing the subject line to make it look like a normal email, but it's a spam email. So that's the very important approach. Adapting to the change by ML. Adapting to the change by ML means your machine learning model you have written must be able to run on the future data sets. That's the first point. Second point is if you have more incoming data than what you have now, plus the data set has more columns, more artifacts, and more features and labels also, it should be able to write. Don't worry about it. We are going to cover each and every small thing we are going to discuss here. Once again, I repeat, as I'm targeting university students and bachelor students, I'm trying to make each and everything so clear for them. That's the reason why I have written slides so carefully, that they are just passed out, they have to understand few things. So that's the reason I carefully written notes for every term. Now let me erase this one. Let me take the pointer. Okay. Now machine learning can help humans learn. There is a controversy here, because the machine learning can only tell you what you are thinking is true or false. That's the first one. Second one is, if machine is telling you that it's true, it can also tell you how far it is true. Machine learning cannot make 100% predictions always right. Please be aware of it. Okay. One thing I wanted to highlight here is, machine learning algorithms can be inspected to see what they have learned. Okay. For instance, once the spam filter has been trained on enough spam, it can easily be inspected to reveal the list of words and combination of words that believes are the best predictors of spam. For example, now your Gmail, go open your Gmail, go and check your spam folder. In your spam folder, you will have all the emails with some kind of similar look, similar words, similar context. Okay, so this is how the machine learning has trained initially on the enough span, but it has easily inspected the list of words that can make the new emails coming in as spam. Okay, if you also agree with me, there is another thing around it, that the unsuspected correlations of new trends can also be correctly understood. Unsuspected correlations mean a new company starting to attract customers initially don't spam, but your machine learning model or your spam classification algorithm running on your Gmail just takes it and puts in your spam folder. You know the reason why? It is trying to find the correlations on what it has learned with the existing data that's coming in. That's the important thing. This correlations bit, we are going to discuss it more and more. So kindly keep this word registered in your mind, correlations. Right? Now, applying machine learning to dig into large amounts of data can help in discover the patterns that were not immediately perfect. This is very important line, guys. Data mining. Applying the machine learning techniques to dig into large amount of data can help that discover patterns that were not immediately apparent. You may fail to detect it today, you may fail to detect it tomorrow, you may fail to detect it on third day, but your machine learning model can have that technique to dig into large amount of data and discover this is going to be one of the rule which falls under spam. That kind of thing it can do. It is called data mining. Okay, so what is data mining? Very important question to understand other areas of uh, machine learning data science. So first thing is, what we have to understand is what did our machine learning learn. Okay, with the existing learning model, is this able to find the unsuspected correlations of the new data coming in? Third one, will this discover me the patterns and let me know that this possible case can also fall under a spam? So this kind of things your machine learning must be able to tell you. For that to get into fit, or to for that to work, you need to be aware of the data mining process in that machine learning approach. We'll talk about this data mining more clearly next subsequent slides. Okay, this is perfect. Now again, let's understand this diagram. You are studying a problem. Yes. You're training your ML algorithm. Perfect. The solution. So there's a big difference from the earlier approach and this approach. The solution is one, two, three. What is the first one? Find all the spam emails. What is the second one? Find the correlations. Third one, in future, will you be able to discover the patterns that were not found now? Okay, if these three subtasks are embedded in this solution, how does that look? And inspect your solution. Okay, once you inspect it, go and understand the problem better. Understanding the problem better means, is there anything else that can be added in the existing model so it solves the problem in future? Okay, and then iterate if needed. This is what it is. Now I love this bit, loads of data. Loads of data means today the machine learning model is working like this. If we have more data, more companies having a workaround on pretending spam emails as good emails, and if they are sending it like that, will my machine learning model handle that? Okay, that is the approach of it. So the thing is, yes, machine learnings can help humans learn, but the predictions, it cannot always make 100% predictions. So we have to be aware of it. Let me erase all drawings and let me take the pointer again. Perfect. Let's go to eighth slide now. Now, summarizing the machine learning. Now we have understood what machine learning is. Let's summarize it. The first point is the problems for which existing solutions require a lot of hand tuning or list of rules. That is machine learning. Perfect. One machine learning algorithm can offer simply a code and perform better. Yes, that's better. The complex problems for which there is no good solution at all using traditional approach. Yes, that's where the machine learning come into picture. Your traditional approach has got no ideal uh, solution, and that machine learning is the best fit for it. Now, fluctuating environments. I told you this, very, very important. Your environment can change, your data may change, your data pattern may change. But if you are a smart machine learning engineer or a data scientist, you plan your approach in such a way that your code need not have to be rewritten. Your machine learning model which you're going to build will work practically. It's plug and play kind of thing. You should be able to write in such a way that your business or your company can use your model on other areas of the business as well. Means the same problem in other departments, I mean to say. Now, machine learning will help in getting the insights about more complex problems and large amount of data. So this is interesting actually. Let's rephrase this one. Machine learning is really great. It is great where the existing solution is required a lot of hand tuning, and it has a set of rules to follow, which becoming more complex. For such for in such cases, the machine learning algorithms can often simply code. It can offer a simple code and that can perform better. You have a complex problem and that problem has no good solution, and your traditional approach is not helping you. In that case, your machine learning can help you. Fluctuating environments mean the environment keeps changing, and you do not have to rework on every requirement that keeps changing. Getting insights. Machine learning is awesome in understanding your business data, visualizing your business data, coming to understanding or making a changes to your business and how you can transform your business. Such kind of things. Now, types of machine learning algorithms. This is very important. This is this is how I can explain you. This one is, how many of you are aware of the difference between classification and regression? Classification is classifying. Regression is making an attempt to get accuracy of what you have found in your process. Now, Machine learning also needs a kind of human intervention. For that reason, we call it as supervised, semi-supervised, unsupervised. Okay. So the first thing is whether or not they are trained with human supervision. Supervised mean yes, it needs a human supervision. Unsupervised mean no, it doesn't need human supervision. Semi-supervised mean at times it needs a human intervention and sometimes it don't need. And reinforcement learning is a bit different, which we will talk in next 2 minutes. Now, whether or not they can learn incrementally on the fly, online versus batch learning. This is very, very important. Most of the companies are how can I say this? In the recent experience of me taking the business interview, they have put forward a typical use case where their data keeps changing and new data keep on adding, and also the model we built must be used for all other problems they have vertically in different departments. For example, you build a model for your HR department. Data is the same, schema is the same, okay, and it worked well there. They just have to plug and play it on the IT department. To run that one, you have to make sure you have to analyze how this data set looks and how that data set looks and how the third data set looks. Comparing all these three things, you need to analyze and write your model. That is what is called online versus batch learning. Will your system or will your machine learning model be able to learn on the fly? Whether they work simply by comparing new data points to the known data points instead of detecting the patterns. This is called instance based versus model based learning. For example, simple guys, let's not complicate it. You have a new data point and you have a non data point. It is comparing the earlier experience with the new experience. Again, go back and think like this. You have an experience E on a task T, and the performance measure P on task T is improved by this much. How is that improved? One step back, your old data points, your new data points. Your machine learning model is comparing your old data points with the new data points, or it need not have to struggle much to detect the patterns in the training and get a predictive model out of it. Most of the scientists that do that. It's like instance based versus model based learning. So let's quickly recap this slide. Machine learning have got different types of systems: supervised machine learning, unsupervised machine learning, semi-supervised machine learning, online versus batch, instance based versus model based. Okay, now let's discuss more. Supervision is it needs a human intervention. Unsupervised means it does not need human intervention. Semi-supervised mean at times it need a person to guide machine learning model to tell yes, your classification business rule is right, please go and implement. If you say yes, it will do. If you say no, it will try a different approach. Now, if your machine learning model is capable enough to learn on the fly, that is online, and if it is not, batch. If your machine learning can understand a new trend and compare the old trend and new trend and detect patterns out of it in the training data and build a predictive model. This is called instance based versus model based learning. Okay, now let's go to the next slide. Now here guys, supervised, unsupervised. Machine learning systems can be classified according to amount and type of supervision they get during training. I have highlighted this. To what account or to what percentage or how much supervision do you need to get the training? First, okay, that is supervised, unsupervised, and reinforcement learning. Let me take the pen. Do you see this? Do you see this? Do you see this? So here, this is one instance. In this instance, it has classified that as a label. Okay. If that label is true, then it is going to classify that as a spam. If new instance comes, what is the story of it? Here, two ways of dealing with it. Initially, if you have built your model of that it's capable enough to handle new data, that's fine. It doesn't need any human intervention. Or if you have just built a basic model and the new data is coming in, machine has detected it, but machine is not sure how to proceed further, then you have to instruct it, yes, please go ahead and do that as well. That is called human intervention. Okay, let me stop this here. So this is 1 minute, guys, and you take out the pointer. Yeah. Now, if you see here, in supervised machine learning, what happens is the training data feed to the algorithm includes the desired solutions called labels. Very simple. The word label is very, very important. Labels, features, samples, test data, training data, correlations, parameters are bread and butter of your data science journey. So always think, what is a label? Label means the training data which you're going to feed to the algorithm has the desired solution in it, but it has to tell you yes what you thought was right or wrong, or it gives you a prediction on what you have thought. Simple as such. Let me repeat it. In supervised learning, the training data you feed to algorithm includes the desired solutions. So simple, boss, very simple. I'll put it in that way. Okay. Let me take the pointer. This is the instance. Let me take the pen. Sorry, not pointer. Pen. This is the instance, right? In this instance, we have 40 emails, right? In this 40 emails, it is trying to classify which one are spam, right? Where is this spam? The spam is present in this data set already. So what is your label now? This spam is the label now. Okay. Now, if you take the new instance also, in new instance also, the case will be the same. But this may have around, for example, this may have around 25 emails. Okay. In this 25 emails, it may have classified 10 emails as spam emails. Okay. Where did this 10 came from? This 10 is nothing but the desired solution, right? What is your end result? What is your end requirement? Your end requirement is to find the spam emails. So out of 100 emails, the 40 are spam, 20 are correctly detected as spam, which is nothing but label. That's what it is. So in supervised machine learning, we use the term called label. So label means in your training data itself, the desired solution is being given and your machine has to find it out, right? Now time for me to clear the pen and get the pointer. Cool. Yeah. Let's go to next thing. Now, labels and predictors. Label, perfect. Earlier, if you remember, I have shown you an example between training set and accuracy. So this labels and predictors is just synonym for that, but in a different way. Let's understand that. Now, labels and predictors. A typical supervised machine learning is called a classification. Okay, supervised. Supervised means it a man is a human intervention is needed is called supervised learning. Now, a good example is I told you earlier already that you have an emails. Your email should be classified as spam or ham, and it must also learn how to classify the new emails coming in. Very good, super. Now, another typical task is to predict target number value such as price of a car given the set of features like mileage, age, brand, etc. is called predictors. Okay. Now let's take it enough of talking with spam, ham, for you, credit card, amazing, spam classification. Enough. We have really spoken so much about them when we understood the basics of it. Now we are talking about a new term called predictors. What is a predictor? Predictor is nothing but this is another typical task to predict large numeric value. For example, the price of a car. Okay, Volkswagen Polo. What is the mileage? What is the age of the car? When was it brought? And how much how much roughly the car was used? The brand, the usage statistics, and everything. Looking at this features. Now understand, guys. Features. What are the features? The input that you are giving. What is input you are giving? Your brand name is one input. Mileage of the car is one input, age of the car is other input. Now, considering the mileage, considering the age, considering the brand, you are predicting the value of the car. What is the value of the car? The price. So what is that called? Predictor. What did we see earlier? Labels. What is a label? It comes under supervised learning that in your training data itself you have a desired results. It's just your machine learning model has to predict that and give it to you. That is label. What is the predictor? You are coming out with a new value, new price of a car, considering you have taken few inputs. Okay. Now this is kind of a regression process. Why regression process? Let me take pen again. I'll put this here. Okay. Why this is called as regression? Because if we have to train the system, you need to give many examples of cars, including both their predictors and their labels. Guys, understand regression means what? I have been. What is the just tell me the meaning of the word regression? Regression means a recursive flow of work. Okay, doing it again and again. Okay, for that one. Okay, I'm going one step back now. Earlier, you have a desired result in your training set itself, and your machine learning model has to predict as a label, well done and dusted, happy. Now you are training your system and you're giving it many examples of cars, Volkswagen, or for example, take Polo, Mercedes-Benz, Audi, or Kia, and many models, brands. That is one example. When you gave example of cars, that cars, each car has got a different brand, different age, different mileage, right? But you have both predictors and labels. Okay, here the label is price. And what are you going to predict? What are you going to predict? You are going to predict a new price. Come again. Let's understand logically. The predictor is nothing but the new value that is coming out of a label. So label versus future versus predictor. Very sensitive area where everybody fall trap in. Try to understand. If you already have a desired result in your training data and you are going to pick that one, that is a label. Predictors mean considering the futures using those features, you are predicting a new value out of it. Okay, but in the regression process, the way how it works is you are training a system and you are giving many examples to it, and this many examples will have both predictors and labels. It has to learn such a way that these predictors and labels should be regressively learned and fast enough to give the predictions more accurately. That is the linear, that is a kind of regression work. We'll talk about it shortly. Now if you see here, this bit here, you don't know the value of it. This one I can say future. X-axis is the future, y-axis is the value. Now what happens when a new instance is added here? You are uncertain, you are not sure what happens, because if you are to be in a position, if your new instance is added, you have to recursively give many examples to train your model with predictors and also labels. So I think we are sure and we understood what is a label, what is a feature, and what is a prediction. Not to confuse, I'll quickly repeat it again. I'll quickly repeat it again. Labels is nothing but your training set itself already has a value or desired result in it. That is label. Futures is using a set of futures, you predict an outcome. Okay, a new outcome. Now, if in a regression you give inputs as both predictors and features, come out with the best accurate predictor is called a regression process. That's the thing. Okay, I will stop this with next slide and we'll continue after that. I have received a feedback that my sessions are going too long and people are kind of are not able to sit for so long. So I'll make it smaller sessions, and I'm going to show you a very important concept called linear regression, matplotlib, numpy pandas, and everything. Stay tuned. This is the first video for today, and once this is done, I will upload the two more videos by end of today. We will be completing the whole process of fundamentals of machine learning. So this is the first bite for today. I'll conclude to the next slide so we can resume it after some time. Now, what are attributes and how these attributes are linked with features and labels? Okay. In machine learning, an attribute is a data type. Okay. While a feature has several meanings depending upon the context. Okay. But generally means attribute plus its value. Kindly understand the difference here. I have file for your information, everything that is in green and everything that is underlined, you have to spend an extra minute on it to make sure you understand the concept pretty well. Please, please, please. Okay, perfect. So in machine learning, an attribute is a data type. For example, mileage. A feature has several meanings depending upon the context, but generally means an attribute plus its value. Okay, let's go one slide back. Okay, now guys understand, here I said features as mile, age and brand, right? What did I say? I said features are mileage of the car, age of the car, brand of the car. Read the sentence carefully. Another typical task is to predict a large numeric value or a target numeric value such as price of a car given a set of features. It's taking a feature and it's predicting a target numeric value. That the predicted value is called predictor. Perfect. So you gave input as features and you got output as predictor. Super. Now you need to train a system. You need to give many examples of cars, including both predictors and their labels. What is this? What is this? Here you gave futures, you got predictors. But here you are including both predictors and labels. Why? Because when you are training your system and when you know that this machine learning model has to work a long term for the new set of data coming in and to adopt the change of the machine learning, you are giving both predictors and values, predictors and labels, so it will go and check it. Now you need to understand, let's link this one with this one. So what is an attribute? An attribute is a data type. Perfect. Now, what is a feature? Feature is nothing but an attribute plus its value. So nothing but this one and this one, predictors and labels. So always remember, do not tend to confuse a feature. I'll highlight this one red because you need to be very much aware of it. Okay. This feature is nothing but you have an attribute that is mileage, and that mileage will be one of the important aspect for you to predict an outcome. So its value is also important for you. That's it. Now, many people use the words attributes and features interchangeably. So if you are going on to a new business or if you are onboarded into a new project, and if they're talking about attributes and features, do not tend to worry about it. I had a bad experience earlier on this one, so please be very careful. Attributes or features are same. Attribute is attribute is considered as one entity, whereas feature is considered as that entity and its consolidated values, or that entity versus dependent variable and independent variable. Don't worry about it. We'll talk about dependent variable and independent variable in subsequent slides. That's what it is. Now, regression algorithms can sometimes be used as classification as well and vice versa. Super, I understand this. I'll explain it in a better way. For example, the logistic regression is commonly used for classification. We are going to implement a perfect logistic regression from scratch today. I'm sure you'll get excited. I'm sure the way we are going to approach it is we are going to understand every pin and every end of it. We are going to understand each and every. If you are writing one line, we completely understand the parameters of that line, and we completely understand how it runs in the background, and we understand how the results are expected. So if you approach that way, you tend to grow the intimacy or love towards the subject. Because see, I'll tell you something. Do you know when you get depressed? The depression comes when you don't know what to do, but you know what to do, but you're not loving it, or you're stuck somewhere. My training is being made filtering these three things. You will be very clear on what you're going to do. And while I was in that journey till here, I know where you tend to get stuck. So I will cover that also. And you know where you're going, and I'm sure you won't get stuck. And if you get stuck, I'm here to help you. And you get excited on the journey that you are learning something, you're achieving something, and all this learn all these days what you have learned, and now what you're going to learn is totally a different what we call permutations and combinations of it. So I'm sure you love it. Now, the logistic regression is commonly used as classification. That's right, as it can output a value that corresponds to the probability of belonging to a given class. For example, you have a spam, out of 100, you have 60 spam emails, but in the first run, only 20% is identified as a spam. In that case, what happens? The probability is 20% perfectly identified. So that is classification. Okay. So your output of the value is always correspond to the probability of the classification percentage. Now, there are many supervised learning algorithms: k nearest neighbors, linear regression, logistic regression, support vector machines, decision trees in random forest, neural networks. We are going to talk about it not now, in future classes, but now you need to understand that there is supervised machine learning, unsupervised machine learning, semi-supervised machine learning, online versus batch, instance-based versus model-based. Okay, we have covered 12 slides, and I have prepared 44 slides with end-to-end implementation of it. So today for this session it's enough. Let's quickly recap and then continue after that. Okay. First thing, what is a machine learning? A quick recap, guys. Machine learning is nothing but a machine program to work on an experience E with task T, where the performance is measured as P for the task P can perform better. Okay. You learn, your machine is learning. Okay. Your machine is learning from experience E with respect to some task T and some performance measures P, where as measured as P, performance improves with every experience in E. Perfect. That's done. Accuracy and training set. I already told you very clearly: dependent variables versus independent variables, training set versus test set, label versus futures, labels versus predictors, futures versus predictors. Accuracy is nothing but when you have run your model on the training set or a sample, what percentage of classification was correct. That is accuracy. Okay. 1 minute, guys. 1 minute. I need to highlight something here. Yeah, this bit. I didn't highlight it. I'm sorry. This particular performance measure is called accuracy, and it is often used in classification task. Go to green, underline it, bold it. Super. Now, why are you using machine learning? You are using machine learning because few complex business problems cannot be solved with the traditional approach, and you may have to write a different code to solve those issues. Machine learning is capable enough of doing it, wherein your machine is learning and understanding with the set of data it has. Your machine learning is capable of adapting the change to the data, and it can run in the long run. Okay. Now, machine learning approach. I told you very clearly. First, understand the problem. Train your ML algorithm. When you train your algorithm, put all the requirements in place. First, the basic identification. Second, stress it more so it can find it the probability to next level. Step 3, considering step 1 experience, step 2 experience, can your machine learning model tell you there are any other possible business rules that can cause an issue in future? Now, adapting change, I explained you very clearly. Machine learning can help human. It can give you a prediction ratio, but may not be accurate. So that is where the supervised machine learning and unsupervised machine learning came into picture. So we have summarized it. This is perfect. This is perfect. Labels and predictors, I explained you very well. Futures labels understood very well. So the next thing is unsupervised learning. We are going to understand. We are going to understand what is detection and clustering, how you can visualize an algorithm, what is your feature extraction and dimensionality detection, and what is anomaly detection, how semi-supervised learning works, how semi-supervised learning and reinforcement learning can be compared, reinforcement learning process continuation, batch and online learning. Why did I leave this slide? Okay, I think I've covered it here. Online learning and how you can how we use online learning to handle huge data sets, instance based versus model based learning, linear regression. This is the amazing bit. I'm sure you all will love it. I'm very much excited to start this today. But if I start this directly without telling you the differences of other things, you won't enjoy it. All my approach here is to make sure every single bit you are learning in this session is a value add so that it will be beneficial for you in the journey of data science. The linear regression part is all practical. I have to show you everything very properly. So this is the whole formula of it, how the linear regression works and how what you need to understand in linear regression. So let's see. We must be able to complete this one today, and I'll upload other two sessions after this one. Thanks everyone for listening to my sessions, and please kindly provide your valuable feedback. It helps me a lot in my future recordings. If you like it, please kindly like the video. I'm going to add it in my playlist. If you hate it, tell me honestly, no problem. I am a person who always take the criticism in a positive way. So your feedbacks will help me. It's not only helping me, it's helping many others who are data science aspirants. Let's all work together. If you have any questions in this process, drop a comment, uh, and I'll respond to your comment. I'm also going to share my blog, my website, and the course content precisely in my website. Those who are interested, you can browse there. And if you're stuck somewhere in the video, you can pause the video and just ask the question at that point where you're stuck, and my team will answer those questions then and there. Because we are targeting real time, so we want the users to have their problems resolved immediately. Okay, it was nice session today, and let's continue the next one in next 1 hour. Thank you so much. Have an enjoyable day.